Hello. So today we will be doing the next part of linear function, which we called it the angle between two lines. So in the coordinate system, as we have learned so many about lines, we can get any two lines. So for example, like that. And today we will be looking at to find out the angle between these two lines, which is this little theta here. And all about its gradient. So to find the acute angle between any two straight lines, all we need are the gradient of the two lines. Okay, so if the gradient of L1 is M1 and the gradient of L2 is M2, then the acute angle theta between the two lines satisfy the following relationship, which is tan theta equals absolute value of M2 or M1 minus M2 over 1 plus M1 times M2. Now, unfortunately, girls, I can't explain to you where this comes from for now, but when we get to the end of term 3 or beginning of term 4, when we're touching the trigonometric function, we'll have a further explanation about this. So basically, this is also a formula that is provided on the formula sheet. So therefore, all you need to do is just put in the formula. So if the gradient of the first line is m1, the gradient of the second line is m2, and therefore tangent value of the angle between the two lines would be the absolute value of such thing. Why absolute value? Because we want to make sure this angle is always less than 90 degrees, because tan value of angle less than 90 degrees is positive. It's positive. So let's take a look how we can actually use this quickly. So example. So given that L1 equals to 2x plus 4y minus 5 equals to 0, and L2 it's 3x minus y plus 6 equals to 0. Find the acute angle between L1 and L2. Okay, take a look. Now, so first of all, remember, to find the angle between the two lines, we need M1 and M2, which are the gradients of L1 and L2. Unfortunately, these two lines now are given in general form. That means you can't just quote a gradient directly. So for L1, we need to change both of them back into gradient intercept form first. 2x plus 4y minus 5 equals 0. Keep y as positive on one side. That gives you negative 2x plus 5, and y equals to negative half x plus 5 on 4. So once you have got this done, you can see this is the gradient. So m1 equals to negative a half. Oh, great. Now for the second line L2, 3x minus y plus 6 equals 0. Now it's better just move y to the other side. 3x plus 6 equals to y. Therefore, y equals to 3x plus 6. And here, this is our second gradient. The gradient of the second line is 3. So now we can actually put this into the formula. Tangent theta equals to negative half minus 3 over 1 plus negative half times 3. Okay, all you need to do is just put this everything into the calculator. Okay, now I am putting this into the calculator now. So tan theta equals to divided by 1 minus 1. Okay, so which is 7. Absolute value of 7. Okay, so therefore now theta is equal to tan inverse 7, which will give you, oops, so tan inverse 7, 81 degrees, 52 minutes, and it's approximately 81 degrees, 52 minutes. Okay, this is just correct to the nearest minutes for this angle. In other words, this is nearly on a right angle, close to 90 degrees. Okay, you don't have to draw the two lines. If you want, you can, but you don't have to. Okay, so let's take a look at another example. Let's take a look at another example. This one is a little bit more complicated, but it should be fine. Now, let's find the angle of the triangle. Triangle formed by the three lines L1, which is 2x plus y equals to 1, L2, 2x minus y equals to 5, and L3, x minus 2y equals to 8. Correct? To the nearest minutes. Okay, so let's take a look. First of all, again, before we do any formula or put it into anything, the very first thing we need to do is to find out the gradient of each of the line. So for L1, 2x plus y equals to 1, y equals to negative 2x plus 1. Remember, gradient intercept form. Therefore, L1 equals to negative 2. And for L2, 2x minus 5, oops, sorry, 2x minus y, put in the wrong formula, minus y equals that, minus y equals to 5, so move it to the right side, so therefore y equals to 2x minus 5, gradient equals to 2. Next one, for L3, what do you have? X minus 2, y equals to 8, again move it to the right side, equals to 2y, and then y equals to half x minus 4. So therefore, m3 equals to positive half. Okay, now there's something you can actually observe before we use the example or use the formula. It is m1 and m3. These two gradients, one is -2, one is half. If you multiply them together, m1 times m3 equals to 2, -2, multiplied by half, which gives you -1. That means L1 is perpendicular to L3. In other words, these two lines meet at right angle, L3. Okay, this is just a numerical drawing. It doesn't have to be actually L1 and L3, but it cuts in the right angle. And all we need to find out is the 2 angle cut by the L2. Okay, so to find the angle between L2 and L1, so L2 and L1 using the gradient -2 and 2. So therefore, tan, let's say theta 1 equals to, because I want to distinguish between the two angles, theta 1, let's say this is theta 2, sorry, that should be theta 1, that should be theta 2, L1 and L2. Okay, so therefore we have, I'll make the positive as my m1, 2 minus -2 over 1 plus 2 times -2. Okay, so if you put this in a calculator, that means tan theta 1 is equals to 413. If you put it in a calculator again, so theta 1 will be equals to 53 point, let's check, tan inverse 3.1301 . So theta 1 is approximately equals to 53 degrees 8 minutes. Okay, and the angle between L2 and L3, let's make it tan theta 2 in this case. Now we're using these two gradients, the gradient of half and the gradient of 2. So let's just 2 minus a half, doesn't matter which one, m1, m2, just use it. And then 2 times half. And you become 3/4. Easy. Easy. Okay. So therefore, theta 2, tan theta 2 equals to 3/4. Theta 2 is approximately equals to tan inverse 3/4 and 36 degrees. 36.8698 and theta 2 is approximately equals to 36 degrees 52 minutes. Okay, now as expected, of course, these two, theta 1 plus theta 2, of course, is equals to 90 degrees, because this one is 90 in here and they add up to 180. Okay, so that's how we use the formula to find out the angle between any two lines. And one special case is if one line is vertical, then we use the formula tan theta equals to absolute value of 1 on m. M is just the gradient of the non-vertical line. Okay, let's continue on the next video.